So today's lab, pretty much the same thing, except we're changing the manipulated variable this time. Okay, last time we were checking what the effect of radius on speed was. Now we're going to check what's the effect of centripetal force on the speed of the object. Okay, so we're still going to be whirling the rubber stopper around and around in a circle, same as we were the last time. What's going to change this time is we're going to change how much the hanging mass is now. Okay, by changing the hanging mass, we're going to put more tension in the string, which will provide more centripetal force on the rubber stopper. Okay, so this time we'll have a constant radius. Okay, it says in the procedure what the radius needs to be. Okay, you keep that radius constant, and all you change is the amount of mass hanging from the bottom. Now, you may need to use more than one mass for some of the trials. If that's the case, that's fine. Don't try to put them through the same loop. Okay, through the same hole, because I see like on some of these that hole's pretty small, right? There's little catches on the bottom. Okay, there's a little rig there that allows you to hook them like this. Okay, so you can just hook them together, and that keeps the mass centered. If you try and hook them together like this, then you start to get kind of a pendulum effect, and it can cause a wave kind of effect in what you're doing. It's hard to keep that nice and horizontal. So keep the masses centralized by hooking them on each other, okay, using that thing on the bottom. All right, so just be mindful of that. Okay, otherwise the procedure is, like I say, pretty much the same. All that's changing in this one is instead of a changing radius, we have a changing centripetal force instead. All right, so the results chart looks pretty much the same as it did before, except instead of having radius here on the left, now we have mass in kilograms on the left. All right, so we're going to calculate our times for 20 revolutions, 2 for each weight. Okay, and then the average time, the period, the speed, and the centripetal force. I don't want you to put it in times 10 to the minus 1 newtons. Just put it in newtons. If it's a decimal, it's a decimal. That's fine. We can live with that. Okay. Incidentally, what is providing the centripetal force here? Gravity. Yeah, gravity is providing the centripetal. It's pulling on the weight. That's what's putting the tension in the string. Okay. So to calculate the centripetal force is really just going, okay, m times g, and we have our centripetal force. Okay. Spoiler alert, that might be useful on Friday's lab, since one of the questions in the analysis was what's providing the centripetal force. You're welcome. Okay. All right. And everyone's like, man, that's so much easier now. I never thought of that. Now you thought of it, sort of, / you were given it. Okay. A couple of things here, guys. Obviously, the variables are similar, but we're going to have to switch a couple of things. What was the controlled variable in Friday's lab is now the manipulated variable. Okay. What was a manipulated variable in Friday's lab is now a controlled variable. Okay. So just be mindful of that. Okay. We're going to be switching those, but the explanations can kind of still go along with each other. The responding variable is obviously still the same. We're still testing the effect of something on speed, so that could stay the same. Whatever you used for your explanation can stay the same. And several other controlled variables are also remaining the same between both labs, so you can reuse a few things there. Okay, for your hypothesis, it's going to be very similar to Friday's hypothesis, except now you're just relating centripetal force and speed. Okay, so if the relationship between centripetal force and speed is this, and the object's whirled around in a circle with increasing mass, then tell me what the graph's going to look like. Okay, what's the relation? What's going to happen to speed as we increase centripetal force? I am going to caution you against something. This is the formula we are investigating. It's very easy for people to look at this and say the relationship between centripetal force and speed is exponential. Is it? The relationship between speed and centripetal force is exponential. Is that true in reverse? It's not. Okay, it is not true in reverse. It may be a slightly different relationship. It's certainly not linear, but it's also not exponential. Google Sheets really only gives you 3 choices, so you'll be able to figure out which one it is when you apply your line of best fit. Okay. So when you're looking at what relationship you want to use on there, you already know it's not 2 of the 3 options. Okay, so you can get the 3rd one and get that one right. Okay, so just make sure you're looking at that. Again, if you don't have the right one in your hypothesis, that's fine. As long as you have it right in your conclusion when you're explaining, I'm okay with that. Okay, so remember, guys, if we're looking here, okay, if we're manipulating this formula for V, okay, we end up with this. It's the square root of FC times R over M. Okay, there's a certain type of name for that relationship. Okay, and so that's what we need to be looking for. All right. So like we say, procedure is pretty much the same, okay, except we're changing the hanging masses and keeping the radius constant. So just make sure you time everything, get the results in that chart. Okay, and then for the analysis, questions like 1, 2, and 3 are pretty much the same as they were for the last lab. You're doing these calculations. Please make sure you show me one example of each calculation so that I know if you have some wonky numbers, I can look at what you did and understand why. Okay, number 4 says determine the force of gravity acting on the mass, record those values in the centripetal force, plot one graph of speed versus centripetal force. Now, that might be backwards. What's our manipulated variable here? Centripetal force. What should go on the x-axis? Centripetal force. Okay, make sure that you do it that way. Otherwise, the graph turns out the wrong way. Okay, so we want centripetal force on the x and speed on the y. Okay, and then the second graph is of the square of speed versus centripetal force. I'm less worried about that graph. We'll talk about it when I hand back the labs and kind of show you what happened. All of your analysis has to do with the first graph, okay, with what's truly going on in the lab, okay, and that is the relationship between centripetal force and speed. Okay, so for number 6, you got to tell me what that relationship is and give me a little bit of an explanation as to why. It has to do with this. Okay, so you might want to make a note of that. You need to explain something to do with the manipulation of that formula. Okay, conclusion, same as always, restate your hypothesis, explain why you can accept or reject it using your data, and then sources of error, are those going to be similar to the last lab? Will they be exactly the same as the last lab? You can save some time on that one too. Okay, so realistically, you should be able to get a lot of this one done because you pretty much have half of it already. Okay, and I have no problem with you copying and pasting stuff from Friday's lab report. In fact, I'm telling you right now, for some stuff, you should probably just do that and save yourself some time. Okay, provided it's right. Don't copy and paste something that's wrong. Okay. All right, any questions on what we're doing? There shouldn't be because you've done it before. All right, go get the stuff, okay, and you can get started on it there.